13.1 starts off with right triangle trigonometry, and a lot of this is going to be review, because if you remember back even to Algebra 1, you were taught the infamous SOHCAHTOA. The big key, the big caution with SOHCAHTOA is that it only works for right triangles. If you do not have a right triangle, you are out of luck. Now, when we're thinking about what are the opposite, adjacent, hypotenuse in any triangle, remember our triangles are often ABC, but they're always named with the vertices being capital. The side opposite those vertices is always named with the lowercase of that same letter, and that's for a purpose. That's so that we can specifically talk about and always be talking the same thing. Trig ratios always depend on where you are. If I start at A, my hypotenuse is always my hypotenuse, but relative to A, that is my opposite. This is my adjacent, because remember, adjacent means right next to, and this is my hypotenuse. So you'll see me a lot of times physically mark which angle I'm talking about and drawing the arrows to the opposite and the adjacent. Now, up until this point, we've always worried about the big three: sine, cosine, tangent. There are three more. And the cool thing about those next three is that you actually don't have to learn anything more. They are all reciprocals of the big three. So sine's reciprocal is cosecant, and you see it's just flipped. Cosine's reciprocal is secant, flip the fraction. Tangent's reciprocal is cotangent, flip the fraction. So, find the values. Now, this means, when it says find the values, they just want the fraction. You don't have to find the angle. You don't want to go out to a decimal. Just give the fractional ratio of those sides. So, angle G. Mark angle G. This is my hypotenuse. It will always be my hypotenuse. Relative to G, this is my side opposite. This is my adjacent. And so the sine of G is equal to the opposite, 24, over the hypotenuse. We always reduce. Common factor of 8, 3 over 5. Cosine of G is adjacent over hypotenuse. Common factor of 8 leaves me 4 over 5. Tangent of G is opposite, 24 over adjacent, 32. Common factor of 8 leaves me 3/4. When I go back, sine's reciprocal is cosecant of 60, of G rather, cosecant of G is 5/3. Cosine's partner is secant. The secant of G is 5/4, and the cotangent of G is 4/3. So it's just simply a matter of flipping those fractions. Now 30, 60, 90 triangles and 45, 45, 90 triangles are also a review from geometry. We know that the short side, because it's opposite the 30 degree, and the long side and the hypotenuse have that relationship of the square root of 3 and a factor of 2. We know in a 45, 45, 90 triangle that the two legs, which are equal, and the hypotenuse have that relationship of the square root of 2. Now this is where we need to start memorizing some things. If I'm looking for the sine of 30, 30 Here's my hypotenuse. My sine of 30 is going to be x over the hypotenuse, 2x. Well, x over x cancels, leaves 1. The sine of 30 is 1/2. I can go through cosine of 30 is going to be adjacent over hypotenuse, x square root of 3 over 2x. Cancel those x's, square root of 3 over 2. Tangent of 30 is opposite over adjacent, x over x square root of 3. Cancel those x's, can't leave the square root of 3 in the denominator, and I have the square root of 3 over 3. Those are values you should memorize. Now, why is it x in here? Because I can make x be 5. And then I would have 5 square roots of 3, and 10. I can blow that up or shrink that as much as I want. Now, I can go through and do the sine, the cosine, and the tangent of 45 in the same way. So the sine would be opposite over that hypotenuse, so x over x square roots of 2. The x's cancel. I can't leave the square root of 2 in the denominator, and I end up with the square root of 2 over 2. Now obviously the cosine is going to be exactly the same, square root of 2 over 2, and the tangent, opposite over adjacent, is 1. If I go back and look at 60 degrees, here's my hypotenuse. What happens at 60 sine, opposite over hypotenuse? I have x square roots of 3 all over 2x. Cancel. Sine of 60 is square root of 3 over 2. What happens with the cosine? X over 2x. X's cancel. 1/2. What happens to the tangent? Opposite over adjacent. X square roots of 3 over x. X's cancel. Square root of 3. Those are 9 values you should memorize. Here they are, kind of collected into a table right here, plus the additional reciprocal ratios, which you can figure out by knowing the big 3, or you have them there for you. Classic review problems. Find the missing value. Based on the angle I know, I have the hypotenuse and the opposite. So that is the sine of 60 is equal to x over 12. Well, if I want the exact value, that means no calculators. So what is the sine of 60 from that table? It's the square root of 3 over 2. That's a straight substitution, equals 12 over x. Little cross multiplying. I have 12 square roots of 3 is equal to 2x. Divide both sides by 2 to get x alone. That cancels. That leaves 6, and x is 6 radical 3. That is an exact answer because you left that radical in. If you had gone to your calculator, you would have some ugly decimal. Now, solve a triangle. Solve means find all missing parts. There could be anywhere from 2 to 4 missing parts that you need to fill in. These are multiple point problems, so be sure to do all the parts. Easiest place to start is always the missing angle because I know these two. So the first thing I'm going to find is that angle y is equal to 180 minus 90 minus 28, and I know that y is 62. Then, based on the given information of these two right here, 11 happens to be the adjacent side, I'll go ahead and find little z, and so that will be that the cosine of 28 will be equal to 11 over z. 28 isn't one of our nice, neat, tidy numbers. So I'm going to go to my calculator and I will get 0.8829 over 1 is equal to 11 over z. Make it into something that I can cross multiply. And so I have z times 0.8829 is equal to 11. Divide both sides by that decimal, and you end up with z is equal to 12.5. Then I start over and say, well, little x is the opposite, and I know my adjacent, so I'm really talking about the tangent of 28 being equal to x over 11. Here I can just multiply both sides by 11, go to my calculator, and I find out that x is equal to 5.8. Now remember, there's a logic to the sides and the angles. The littlest angle will have the littlest side, so it makes sense that opposite the 28-degree angle is the 5.8 side. Opposite the 62-degree angle is 11, and the hypotenuse should always be the biggest, and it is at 12.5. If any of those values are out of order, you know you did something wrong. Find the missing pieces again. So here we need to find the angles. And to find the angles, we need to use the inverse function. It's not a -1 power. There is actually a button on your calculator, usually right above the sine or the cosine, and it looks like that. On some of your calculators, it's going to be called the arc sign. Those are the buttons you want to use. So here, solve, we need 3 angles. You can start anywhere, well, 2 angles because we know one is 90. You can start anywhere. I'm going to start with B. In this case, I can use any of the trig ratios I want. I'm going to use sine because I can. And so I know that the sine of B is equal to 14.4 over 17. So when I go to my calculator and I enter this, I'm going to get approximately 58 degrees. Now at this point, I could find A by subtracting, and I would have it. But what if I did B wrong? So a nice way to check is to simply back up and say, well, let's find A on its own merit. So the sine of A is equal to 9 over 17. So the inverse is approximately 32 degrees. And if you take a quick look, if those don't add up to something close to 90, you did something wrong. Now this last little bit is a classic trig. Basically, word problems. If you are going to look up to measure something, that is an angle of elevation. Looking up at something. If you look down at something from a vantage point and you are looking down, that is your angle of depression. And that will help you draw and build your triangles to use your trig ratios. So for example, the aerial run in Snowbird, Utah has an angle of elevation looking up of 20.2. Its vertical drop is 2,900 feet. Estimate the length of the run, L. They don't want to know how far we are from the mountain, so always be sure you know what value. Now, this angle, I know the side opposite. I happen to want the hypotenuse, and so I'm really talking about the sine of 20.2 being equal to 2,900 over what I don't know. Cross multiply and go to your calculator. I have 0.3453 over 1 equals 2,900 over L. L is 832. 98.5 feet.